we pick up with example 3 on the backside of notes. An airplane is traveling east at 600 miles an hour. Another is traveling north at 750 miles an hour. Gotta draw my picture. Traveling north. Traveling east. It says if they left the airport at the same time, how fast is the rate of their distance apart increasing after 2 hours? So this sounds like a complicated problem, doesn't it? Very good. So Larry's able to visualize it, which is the first most important part, that we are wondering the rate at which their distance is increasing. Okay? How fast is the rate of their distance apart increasing? Okay? So we're looking for d prime, that distance. What would you like to call this variable here? N for north. Do you know n? Do we know n prime? Yes. Do we know e? Do we know e prime? Okay. Can you come up with a formula that relates n, d, and e all together? N squared plus e squared is equal to d squared. We don't include any of the primes yet. Is north changing? Is the distance north changing? Is the distance east changing? Is the distance apart changing? What else is changing that these are all changing with respect to? Time. They're all, most of the time it will be time, yes. So that's the underlying rate that is making all this possible, okay? What? Oh, yes. Let's get the distraction out of the way. Okay, we got that out of the way. N squared plus e squared equals d squared. Shh. I'm taking the derivative with respect to time. Let's watch what happens. Because this is sometimes the way that people go about these type of problems. Shh. N squared plus e squared equals d squared. If I take the derivative with respect to time, again, does the variable t pop up in here at all? No, so therefore it's this implicit differentiation type process. We have to attach a prime to each one of these derivatives. What is the derivative of n squared? 2n n prime plus 2e e prime equals 2d d prime. So you can see, so we have a lot of different variables here that we need to know. First of all, do you know n prime? What is it? 750. Do you know e prime? 600. Do we know d prime? No, we're trying to find it. That's the whole point. In order to find d prime, I have to also know, as you can see from our equation, I can only have one unknown variable if I want to solve. So I have to fill in n, e, and d. So n, e, and d. Anybody have any ideas how I will find the north distance, the east distance, and the distance apart at this time? Very good. I've been traveling for 2 hours. If I've been traveling for 2 hours, very good. Is anybody confused about how we came up with those? No, I'm traveling at 600 miles per hour. So I travel 600 miles in 1 hour, and then another 600 miles in the second hour, so that's a total of 1,200. How do I figure out D? Yep, the Pythagorean Theorem. And if we use the Pythagorean Theorem, we have, take out my calculator. Go gadget calculator. Okay, so Emma has the answer. She works this out. She used Pythagorean Theorem and came up with 1009. $1,920.9. Is that correct? Okay, very good. All right. So, can I now plug in the appropriate variables in order to solve for d prime? Yeah, so this becomes 2 times the north distance, which is 1,500, oh, Mr. Getz. Okay, 2 times 1,500, we'll just do it, 3,000, times my n prime, which is 750, plus 2 times e, which is 2,400, times my e prime, which is 600, equals 1,920.9 times d prime. I multiplied 2 times the 1,500 to get 3,000. Oh, I'm sorry. Yes, yes, very good, thank you. So this becomes 2,841.8 d prime. Yes, I did that one too. So we have 3,000 times 750 plus 2,400 times 600. I mean, it's gonna be okay there. And I'm going to divide that result by 3,841.9, and I get 960.46. What's my label? Miles per hour. Does it make sense that that number is greater than the other two rates? Yes. Any questions how I figured that out? Question going once. Question going twice. 3 times and sold. Okay, we do one more problem, then I'm going to give you a bunch of problems that you can just experiment with and try. So, this is a classic problem, and I would encourage you that there's a very good chance you're going to see something like this on your take-home test. Okay, so again, I hate take-home tests, but that's what we're going to do. It will save us some time as well. Partner tests, I hate those even more. So, all right, so we have corn is being piled, emptied into a pile at a rate of 12 cubic feet per minute. So, if you're dumping corn, what shape does that pile make? A cone. Very good. So I'm going to draw a cone. It's wondering how fast is the height of the pile increasing when the pile is currently 6 feet high and has a base diameter of 8. So I've got a base diameter of 8, and I've got this height right here, which is 6, and it says that I want to know h prime. Somebody tell me, what do I need to know? What kind of information do I need to write down? Got it. So I got h prime right there. What else do I need to write down? Volume of a cone. Volume of a cone is equal to 1/3 pi r squared times the height. We know v prime. What's v prime? 12. We know the current height is what? And we know the current radius is 4. So we have some pieces that we know. Did the last problem we did it end up having one variable or two variables? Or three variables? 3. And we were still able to solve it, right? That doesn't always work in this situation, okay? Yes, question. We don't have h prime because it's asking how fast is the height of the pile increasing. That's what we're trying to find. That's the question. How fast is the height of the pile increasing? We only know the current height is 6 and that the diameter is 8. So here's the problem. As you continue to work this problem out, I'll just swatch. Okay, if I were to take the derivative of this right now, which rule would you have to use? The product rule. And when you do the product rule, you would have the derivative of this part times this left alone plus the derivative of h times that left alone, right? When you take the derivative of this first part, the green part, true or false, you're going to come up with an r prime somewhere. True. Are we trying to solve for r prime? No. Do we know r prime? So that creates a huge problem. So the foresight in this problem is to realize, even though the last problem I could have those 3 variables, I knew those rates. If the problem said you know the current rate at which the radius is increasing, then we'd be okay. But we have no idea. And so if we use the product rule, we're going to be out of luck. Okay? So therefore, I have to get rid of that radius. So we can do that. Here's a little trick. What shape do you see inside the cone? Triangle. And you know that within your triangle, okay, you know that the triangle, if I have this triangle here, and then the pile grows, okay, I'm going to draw another, I'm sorry, not a triangle, but what shape is this? Cone. As the cone grows, you guys tell me, I get another triangle, right? And those are going to be similar shapes, are they not? So that means that the triangle is growing proportionally. That the height and the radius grow in proportion to one another. So what I'm going to do is I'm going to do a little trick here. I'm going to set up a proportion. The height of the cone divided by the radius of the cone, that's going to always remain at that constant proportion. What is the current height of the cone? 6. What is the radius? 4. I can now solve for the variable. Which one do I want to get rid of here? Do I want to get rid of the r, or do I want to get rid of h? I want to get rid of r because I'm trying to solve for h prime. So we're going to get rid of r, so I have to solve for r and substitute in for h. If we cross multiply here, we get 6r is equal to 4h. Divide both sides by 6. You get r is equal to 2/3 h. And that's a constant scenario here, okay? Because we just understand that as this grows, you're going to have similar triangles. So we're using a very geometrical idea here as well. So we're going to plug that in. Volume is now equal to, I need to write a new equation so I don't have to use the product rule. 1/3 pi times, instead of r, I write 2/3 h squared times h. Little billy. Okay, now we just got a little algebra. We've got 1/3 pi. What's 2/3 h squared? 4/9 h squared times h. Well, I could simplify that. The volume is equal to 4 pi over 27 h to the third. I haven't taken the derivative yet. I've not taken the derivative yet. All I'm doing is creating a function of the volume in terms of h as opposed to r and h. Now that only works, you guys, only works because we know the radius and the height. It could be different. You could have a different problem. It's not like you can walk back to your geometry teacher and say, hey, we came up with a new formula for volume. No, this is not always that way. Only when it's that proportion. Okay? So, we want to take the derivative with respect to what variable? Time. Time is the variable that is changing for all of these. All of these, time is, as time moves on, the radius is getting bigger, the volume is getting bigger, the height's getting bigger. That's what ties all this stuff together. So I'm taking the derivative with respect to time of volume equal to 4 pi over 27 h to the third. What's the derivative of v? V prime, or 1 times v prime, which is v prime, equals 12 pi over 27, which reduces to 4 pi over 9. H squared h prime, very good. That's my derivative. Now that I have the derivative, do I have enough pieces to solve for h prime? I sure do. What is v prime? 12 equals 4 pi over 9. What's the current height? 6. Square it. Divide both sides by 36. We get 1 over 3. If you want to convert it to a decimal at any point here, that's absolutely fine. I'm just going to... Now I'm going to multiply by the reciprocal. So 9 over 12 pi is equal to h prime. 9 over 12 pi can reduce to what is your label? Very good. Let's look at what we're measuring. Okay, we're measuring height, correct? When you measure height, do you measure it? Right, you measure it just. It's a single, one-dimensional measurement. Okay, let's draw some analogies, everybody. Okay. The beginning. Do all the problems involve a visualization? They do. Okay. Do all the problems involve a derivative? Do all the problems involve a solving? Yes. This is where things get a little wacky, right? It's that second box where you got to figure out what do you need for your equation. Can I use the product rule? Sometimes you can. Again, if we had r prime up here, we could use the product rule, but we don't have r prime, so we can't use it. So we need to do something like that. So I gave you 4 problems. These are classic related rate problems. There are many, 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 many more. What I want you to do right now is take out a scratch sheet of paper you can do for your homework. I'm going to hand out your assignment, and I just want you to work and try to get through as many as you can right now. Yep, WQ. So Cody and Brooke, if you're watching, I have a worksheet that I gave the class, and they were supposed to do the first 6 and then pick 3 from the second set. And so, anyway, I hope to see you guys soon. Bye.